Okay, Ji. We are starting off with the first live session. So let's see how it goes about, and then we'll work out accordingly. The question is very clear. The question says that P and Q are points of the circle center O with radius 4. POQ is 130. Calculate the area of the triangle POQ. ठीक है जी. So you already know that the triangle is inside this. So if we just work upon this, this is your triangle, right? So isosceles triangle, this is 4, this should also be 4 because if this is radius, this will be also your radius, and this will be your normal chord. So can we just work upon this and say that your area will be half into A into B into sine theta. So this is your general formula when you have the non-right angle triangle, half into A into B. A and B are basically the adjacent sides of the angle. So if we are taking this angle, we'll be taking the adjacent sides. So we know that this is going to be half into 4 into sine 130 degree. So the area is 6.128. So leave your answer like this or just change it to three significant figure, that would be 6.13. So 6.13 centimeter square will be your answer for part 1. Calculate the area of the major segment. Now major segment you need to have shown unshaded. Now you need to be very clear that you need to have the unshaded area. So if we just take out this particular angle, this angle will be 230 degree. This angle is going to be what? 230 degree. So we already know the area of the triangle. Now we need to take the exact area of the triangle. So area of unshaded region will be area of major sector plus area of triangle. Area of major sector plus area of triangle. So area of major sector is 230 divided by 360 into pi and 4 square, right? Plus the area of the triangle was 6.128. So we'll be taking down the calculator and then solving down, adding 6.128. So the total angle is 38.24 centimeters square. So this is your question number 14. Remember, this is June 2014, paper 2 question number 11, part B, and question number 14 from my book. So here we go about. Let's just work upon question number 15 now. So giving you just how many minutes? 4 minutes to attempt both parts. Attempt these for 15 part 1 and part 2. Okay, I want you to attempt this question number 15. Question number 15. It says that the cross section of the prism is a sector of the circle, radius 8 centimeter, and angle is 40 degree. The prism is 20 centimeter long. The prism is 20 centimeter. Calculate the area of the cross section. So if you want to find out the area of the cross section only, so that means we will be working down with the sector, because it just needs the area of the cross section, and the cross section of the prism is the sector of the circle. So that means we need to find out the area of the sector only. So area of the sector becomes the area of the cross section, 40 upon 360 multiplied by pi, and the r is 8 square. Because the sector formula is theta upon 360 into pi r square. This becomes, tells you the area. So the answer for this using the calculator will be 22.3 centimeter square. Similarly, in the next part, the question clearly says total surface area of the prism. Total surface area. Now, these type of questions are very pretty much easier to understand if you just know the concept of the total surface area. Total surface area means that basically you need to find out the area of the whole. You need to find the area of the entire shapes that you have. So, what do we have in this? Number one is the sector. Now, this sector is going to be, there would be another sector behind this, right? So, obviously, there will be two times the area of the sector. There will be two times the area of the sector. Similarly, if you agree to this, you should also agree, since the shape is like this and there is an arc, so automatically the shape below will be like this as well. So that means the rectangle will be there will be two rectangles as well. One here and one at the bottom, just to finish the arc. So obviously the length of this is 8, then the length of this should also be 8, right? So particularly, there are two sectors, there are two rectangles. There are two rectangles. And most importantly, there is a curve surface area that will be part of the square. There is a curve surface area as well. So if there is a curved surface area, so what we need to understand is that how we going to take out the surface area? We're going to go about this, that your area of sector, when we calculated, was 22.3. So this will be multiplied by 2, right? Then you have two rectangles. So 8 into 20 multiplied by 2. And there is a curved surface area, 40 upon 360. And the curved surface area is calculated through what? Theta upon 360 into 2 pi r. This is curved surface area formula, right? Theta upon 360 into curved surface area. And then automatically we multiply this with what? H. We multiply this with what? H, because this is just the arc that we are talking about. Just the arc. So let's say arc curved surface area. So 40 upon 360 into 2 pi r, which means 8. This will give me the arc multiplied by the length. This will be 20. So when we multiply this, 22 into 2 will be 44.6. 8 into 20 into 2 is 320. And this will be 111.70. So when we add them, 44.6 plus 320 plus 111.70, the answer of this is 476.3 centimeter square. Centimeter square. So this is what we need to find out when we are dealing with what? When we are dealing with the arc. See, now this is paper 2 question, remember? Since this is paper 2 question, you need to understand the shape yourself because it's a cross section. And in this cross section, see, this is your sector. This will be your sector as well. Okay, ji? So this was question number 16 from the book. And November 2014, paper 21, question number 10, part B from the year that we will be measuring. So let's just start off with question number 16 as well. All right. Let's just start off with question number 16. Start attempting question number 16 so that you guys know that how much you are able to solve this question as well. So question number 16, attempt part A and part B first. Part A and part B. Okay, जी, question number 16. क्वेश्चन क्या कह रहा है भाई? क्वेश्चन को समझते हैं फिर क्वेश्चन को आगे बढ़ते हैं ना. The diagram shows perimeter of 400-meter running track. It consists of rectangle measuring 1100 meters. So if this is 100, so this should be also 100, considering, right? By the d meter as the length, the height, and two semicircles of the diameter d shape, the length of each semicircular arc is 100 meter. Calculate d. So what does it mean? It means you need to calculate the diameter of the semicircle. You need to calculate the diameter of the semicircle. So what we need to understand is that what will be the value if the question clearly says that the two semicircles of the diameter d meters. Diameter d meter. The length of each semicircle arc is 100 meter. Each semicircle arc is what? 100 meters, right? So considering this as what 100, so what we can have is half, that is 100. And what do we have is 2 pi r is for the entire circle divided by 2. 2 is cancelled. So 100 is equal to what? Pi r. 100 is equal to what? Pi r. So if we just take the entire d, so what we need to have is 100 is equal to 1 upon 2 pi, and we can have d. Since we are dividing it down, so eventually we can write down, replace this d as what? R as d, and obviously we can replace this pi and d with 1/2, ताकि obviously जो d है वो हमारे पास क्या आ जाएगा, रेडियस आ जाएगा। तो अब मेरे पास क्या करना है, जब मुझे पूरा डी चाहिए तो मैं डिवाइड बाय 2 कर सकूँ, या फिर आर निकालने सिंपल मल्टीप्लाई बाय 2 कर दीजिएगा, दैट इज ऑल अप टू यू, कोई ऐसा इशू नहीं है। सो व्हाट द वैल्यू ऑफ डी विल बी 63.662, जो कि क्या बन सकता है 63.7, सो वी हैव 63.7 एज व्हाट डी। Then we have calculate the total area of the region inside the running track. ठीक है जी, अब inside the running track, what do we have? We have total area of the region includes area of rectangle plus area of two semicircles. Area of rectangle and area of two semicircles, right? So area of rectangle will be 100 into the normal length that we have, because the question wants us to find out 100 into 63.7. 100 into 63.7 plus your area of two semicircles. So this should be half pi r square. So this should be 31.83 when we divide the diameter, right? And then we can obviously multiply by 2. So this will be 6366.2 plus, when we solve this, we end up having 3182.9. So the total area of the region that we have it was, the total area is 9549.1, which can be written as 9550. So this becomes the area of the region comparatively. Part C. So we have a shape here, right? So part C says S is the starting point, right? S is the starting point and finishing point of 400 meters. Fine enough. We start from here and then we end. We move around, and then obviously this will be your track, right? For 400-meter race. This is your 400-meter race. For a runner inside the lane. A runner in an outer lane is always 3 meters from the inner perimeter. The runner in the outer lane starts at A and comes here so that it meets the winning line, right? It starts at A, runs 400 meters, finishes at T. So TS is 3 meters. Calculate the length of the arc of TA. So you need to have this arc, right? So if we need to have this arc, so there needs to be certain things in between them. So the outer radius, the inside radius is with this help, right? So this was what? 31.83. This was 31.83. So let's say from here till here was 31.83. So this is your 3. So automatically this will be 3 as well. So we add 3 for the outer radius, right? So the outer radius is 31.83 plus 3, which is 34.83. ठीक है ना? हमें नजर आ रहा है कि भाई ठीक है, ये जो पॉइंट है यहाँ से लेके यहाँ तक, दिस बिकम्स योर रेडियस, जो ऊपर किया था, और ये बोल दिया था कि भाई 3 मीटर बाहर है, तो हम उसको ऐड कर देंगे तो हमारे पास पूरा हमारे पास आ जाएगा। ठीक है, पेरीमीटर अगर मुझे आउटर लेन का चाहिए, ठीक है, पेरीमीटर जब मुझे आउटर लेन का चाहिए तो मुझे जाहिर सी बात है, ये तो मेरे पास यहाँ से लेके यहाँ तक तो 100 है, और यहाँ से लेके यहाँ तक भी 100 होगा, तो ये भी 100 और ये भी 100। पर जो फर्क होगा वो यहाँ पे होगा, द डिफरेंस विल बी इन दिस पर्टिकुलर आर्क, right? So normal is pi r for one semicircle. But when we talk about this, we also talk about the same arc that is here. So this should multiply by 2. This should multiply by 2 automatically. So this is 2 pi and the r will be 34.83. So what do we have? We have 2 pi 34.83 plus 100 plus 100 will give me the outer line perimeter, which is equal to what? 418.84. Right? The question is clear. And but calculate the length of the arc of TA. Calculate the length of the arc of what? TA. We need to calculate the length of the arc of what? TA. That means we need to take out the difference. We need to take out the difference. Since we do not have the angle, we need to take out the difference. Because the difference will generally be with the help of what? The outer perimeter and the inner perimeter. So 418.84 minus 400. This is your outer perimeter. This is your inner perimeter. And we subtract it, we have 18.84. We subtracted, we'll have 18.84. So 18.84 meter is basically the distance of what? TA. That means this particular arc is 18.84 meters. Because the difference will be the only difference that is there to change this. The racer will be, one racer will be here, the other racer will be here. And the difference between that is out with the help of the outer perimeter. So considering this point, now what we need to have is O is the center of the semicircle part of the track. Fine. Calculate AOT. Now, since we know that arc was 18.84, radius of the outer perimeter or outer sector was adding up 3 was 34.83. Right? This was 31.83 plus 3 becomes what? 34.83. So this is your sector. This is your sector, right? So if we have this sector, and we know this arc as 18.84, we know the radius as well, which is 34.83, right? So what we're going to use is we'll be using the arc formula, that is theta upon 360 into 2 pi r, which will give me arc. And we already know the arc is 18.84. We do not know the angle, but now we know the radius, that is 34.83. So the theta will be, when we solve this together, so the angle AOT is basically 31 degrees. This is your 31 degrees. Now this was generally question number 16 from the book, right? This was 16 from the book, and yearly, this was November 2014, paper 2 question number 5. November 2014, paper 2 question number 5. Okay, Ji. Next question, let's just try attempting 17 part A and B. Attempt 17 part A and B. Okay, the question number 17. So what do we need the volume of the cone is there, volume of the sphere is there. A solid is formed by joining a cone of the radius 4.5 centimeter and the height of 7.6 centimeter to the hemisphere. The radius is 4.5 for both, right? Calculate the area of the circle where they are joined. Area of the circle. So, particular, what do we need? We need this. This area of the circle is required. So, the radius is 4.5. So, it's very easy. It is pi r square. Area will be pi r square. So, pi radius is 4.5 square. So, the answer for the area is 63.62. Total volume of the solid. So, volume of the solid. Volume increase has the cone and the hemisphere. Volume has the cone and the hemisphere. So we need to understand this, that we need to go about the cone and the hemisphere volume. So volume of the cone is 1 upon 3 pi r squared h plus half 4 upon 3 pi r cube. This is volume of the cone. This is volume of the hemisphere. 1 upon 3 pi 4.5 square and the h is 7.6 plus 1 upon 2 4 upon 3 pi 4.5 cube. So when we solve this in calculator, we end up having the answer as what? 352. 352. Similarly, in the next part, it says another solid of the same type is made by joining the cone of the radius 5 centimeter and the height is 8 centimeter to the hemisphere of the radius 5 centimeter. The cone and the hemisphere have equal volumes. The cone and the hemisphere have the calculate the height. So the cone and the hemisphere have the equal volume. So what do we need to understand? Volume of the cone is equal to volume of the hemisphere. क्योंकि दोनों को क्या बता दिया कि इक्वल है ना. So if these are equal, then automatically we can write down equal to sign. And the volume of the cone formula is 1 upon 3 pi r square h is equal to 1 upon 2 4 upon 3 pi r cube. Now, since we need to find out h, we can easily find out the volume of hemisphere. So, because the radius is same, right? So 1 upon 3 pi 5 square h is equal to 1 upon 2 4 upon 3 pi 5 cube. So if we solve this together and to find h, obviously we'll cross multiply with the numbers, solving 5 square as what? 25, 5 cube as 125. Or you can eventually cancel every number, like 3 and 3 can be cancelled, the square can be cancelled by cube, so you'll be left with power 1. The end result h will be 10 centimeter when you solve it through the calculator. So 10 centimeter is your answer. This is June 2015, paper 21, question number 4. And remember, this is question number 17 from the book. This is question number 17 from the book. So these are the type of the question that can be tested in your normal part of the examination, since these are part of your paper 2. Let's attempt question number 18. Question number 18. We'll have a look, attempt part 1 and 2, easier. Okay, let's just start with question number 18. अच्छा, question number 18 क्या कह रहा है? The diagram shows a sector. Now this is part, this is yearly. It's a long question, June 2015, paper 21, question number 8. ठीक है जी. So the diagram shows a sector AOB. Calculate the length with radiuses. Calculate the length of the major arc AB. So calculating major arc is very easy. The formula for this is theta upon 360 into 2 pi r. The arc is theta upon 360 into 2 pi r. So theta is 260 upon 360 into 2 pi, which is 9.3. The answer is 42.20. So we write it as 42.20. Calculate the area of the major sector AOB. Calculate the area of the major sector AOB. So major area of the major sector. So formula of the major sector is theta upon 360 into pi r square, right? Theta upon 360 into pi r square, which will be 260 is the theta, 360 into pi, 9.3 square. So the area is 196.2. 196.2. ठीक है जी. Then comes part B. Now remember that sometimes your part A is automatically linked to part B. The sector of the radius 0.8 center O is removed from the sector AOB. Okay. So as shown in the diagram 1, the shaded shape is used to make the part of the conical funnel. Fine. AD is joint to BC. AD is joined to BC. Fine. As shown in the diagram in part 2. Fine. So what do we need to have? The circumference of the top of the conical funnel is the major arc of AB. The circumference of the bottom of the conical funnel is the major arc of CD. Calculate the external surface area of this part of funnel. First thing first, that means that this is linked. The arc, major arc, is basically the circumference. The CD smaller arc is basically the base, right? So what you need to calculate is the total surface area of the funnel. So what does total surface area includes in this? Your total surface area. We already know that the angle that we had was, this is your radius, right? This is your radius. We already calculated 196.2 for the entire sector. So can we just remove this smaller part? Can we just remove the smaller part to have what? The area of the remaining, to have the area of the remaining part. So what we can have is area of sector, major sector, minus the area of radius 0.8 sector. So this was 196.2, which we calculated. So the other one was 260 upon 360 into pi 0.8 square. So the end result that we will have is 194.75, which will be 195 centimeters square. Which will be 195 centimeters. Now you don't need to calculate anything else other than this, that okay, this the entire sector can be removed so that we can have the entire surface area of this. Then the funnel is completed by attaching an open cylinder of height 5 to the bottom, right? The funnel is completed by attaching an open cylinder of height 5 centimeter to the bottom by a conical part. Fine. Show that the radius of the cylinder is 0.578, correct to 3. Now, the arc of CD is important here. The arc of CD is important here. The arc of CD is the circumference of the funnel bottom, right? Now, this arc is basically the circumference of the funnel funnel bottom, right? So what we can do is we already knew that this was 260 upon 360 into 2 pi 0.8. And this should equal to what? 2 pi r. This should equal to 2 pi. So r will be 0.578. So the r will be 0.578 of the cylinder. Calculate the external curved surface area of this cylinder. Now, curved surface area formula is 2 pi RH. So 2 pi R is 0.578 and H is 5. So 18.16 is the answer. Calculate the volume of the cylinder. Base area into height is the formula of the volume. So pi r square H. Pi r is 0.578 square and H is 5. So this is 5.25 centimeter cube. So if you just see what we can have is that the question that we did respected to the mensuration of paper 2 up till now, that means that most of the time, if the difficult question is there, they will test you difficult in the first part, but then eventually they will make it easier for you. Now, if normally what students do is that they see the first part and they don't attempt the last parts. Even if you write the formulas here, you just attempt this, you might end up getting 1 mark from each part because this is very easy, right? But again, the only concept that will linked was through the theoretical part. If you can understand the theoretical part here, then it will be very easy for you to complete the question. So this was question number 18. And this was particularly June 2020, June 2015, paper 21 and question number 8 from the book. So that's about it for today for O-level maths. We completed few questions of mensuration from the book. We did 15. We started off from question number 14, 15, 16, 17, and 18. Thank you.